All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's July 14th, 2021. My name is Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with your team while showing them the ropes. If that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered. So feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can subscribe for these live and interactive sessions by heading over to cloudposse.com/officehours. Again, that's cloudposse.com/officehours. We host these calls every week. Our call is recorded. We'll automatically post a video recording of this session to our YouTube channel so you can follow up and share it with your team. So with that said, let's kick it off as I find my window here. Cool, sweet. So got a couple announcements. Just want to remind everyone, next Wednesday, I believe we're going to have Taylor Dolezal present on Waypoint. That's going to be really rad. Waypoint is HashiCorp's kind of continuous delivery product, you could say, or /PaaS, self-hosted PaaS alternative. Haven't really seen too much about it yet, but hear really good things. So do tune in next week if you want to learn more about HashiCorp Waypoint. One of the cool things that has reached, what is it? It's not that it was just released, but maybe hit 1.0. Amazon is officially backing a Kubernetes native way with custom resources to manage AWS. So you can deploy a custom resource to create an IAM role or create an S3 bucket. In some ways, you could say it's similar to maybe using a Terraform custom resource with Terraform Cloud and being able to provision resources that way. So this is called AWS Controllers for Kubernetes. And this is, I guess, in a developer preview still then. But there's been a few false starts with this. Those of us who have been doing Kubernetes and wanting to do something like this for a long time, it was originally the AWS Service Operator, I believe it was called. Then there's been other formats or variants of this that basically use CloudFormation behind the scenes. But what makes controllers for Kubernetes more unique than the other approaches is that they are directly leveraging the AWS SDK under the hood, and they're not just relying on CloudFormation templates anymore. I believe there's it uses a code generator pattern so that it should follow updates more closely as they're released to the underlying SDK, which is the big problem we have with Terraform, right? That Amazon releases a new feature and we got to wait a couple of weeks or longer to even use it in Terraform. So I think this is interesting. It serves a specific use case in my mind. Like, you probably won't be using this to deploy clusters. That's not even supported right now. It supports a limited subset of AWS resources right now. But like, look, you're going to have a VPC, right? And well, this is not going to create your VPC for you because you have to have a cluster to begin with before you get that. And yes, you could ultimately say, well, there's other cluster provisions, there's other environment, there's other VPC and all that other stuff. I don't see that. That's not an architecture that stands out to me that I would like to support. So therefore, let's look at what the value is of this. And I think the value is you want to enable product teams, developers to do the most common kinds of things on their own without having to complicate things, introducing Terraform continuous delivery together with your application continuous delivery. So when you use ACK, you get this custom resource that you can then create an IAM role that your service uses to talk to an S3 bucket. And all of that could be captured in a Helm chart or in Customize or however it is you're deploying your Kubernetes applications. Has anybody already kicked the tires on this developer preview for ACK? Not you, Andrew? Haven't seen you around for a while, Andy. Good to see you.
I moved to California. I've been moving for the last 3 weeks.
Right. That's right.
Well, I've been on the road. In Needles, California, it was 125 degrees. We were like, yeah, no.
I know. I saw the windshield screens were, or dashboard, what do you call them, to protect your cars, dashboard, were melting for people. It was insane.
This is the first time I'm hearing of this, so no, I have not kicked the tires.
Okay.
It looks interesting.
Yeah. So AWS controllers for Kubernetes. All right. So the other announcement would be Amazon. Oopsie. Amazon coming out with their own bona fide training program here via Twitch. So Amazon bought Twitch as a streaming platform, and now they're going to be putting out learning materials so you can become AWS certified, or to make it easier to become AWS certified. So they're starting with AWS certified solutions architect, and they're going to keep adding on to this. So this is cool. It's a free channel to get study up on getting certified. There was another interesting thing I came across. I clicked on the wrong link here. I mostly skimmed over it a little bit because I hadn't read too much on how Lambda operates behind the scene. Now, what is it, like 2 years ago, they released an open source Firecracker. So Firecracker is their ultra lightweight micro VM platform. So you can run individual commands basically in their own dedicated virtual machine, which is more secure and more isolated than containerization. So this goes into a little bit about how it's architected, what the stack looks like, and the flow. The request flow for how AWS has implemented Lambda. What I didn't look into who this is. I was kind of surprised to see this coming up on not Amazon's website, but some blog post. So. All right, then this was a really exciting announcement, or discovery for us rather. It's really funny. RB on our team was deploying a new EKS cluster, and he's like, why did that go so fast? What did I do wrong? And well, it turns out just on July 2nd, they released support for parallel rollouts for EKS managed node groups. And it works by, it's configurable by setting the percentage or the number of nodes that should be upgraded at the same time. I tried to see if support for this has already been added to Terraform, and I couldn't. At a first glance, I didn't see it. But I guess behind the scenes, it's using some better defaults that make upgrades faster, because before it was really brutal because it would drain and cordon one node at a time, and if you had a 50 node cluster, you can imagine how long that would take. And let's see here. This was I really enjoyed this article. Anybody who's been using Helm for a long time is probably a little perplexed as like, why are CRDs still not a solved thing? Like, what's so hard about it? I can just run kubectl apply and get my CRD. So if I can do that, why can't Helm do that? And the reality is there are so many ways that custom resources are used. There's so many risks using custom resources. And every time they tried to implement something, it never made everyone happy. So that's kind of like why they've just reached a happy medium right now, where they'll deploy CRDs, but they won't delete them. And I guess it'll also it'll also help with upgrades still. The gist of it is that when custom resources were first conceived, they were a way, I think, of how Kubernetes would manage other primitives like deployments. So like a deployment you could think of like a custom resource, but it's not. It's a first class resource, but it creates then replica sets, and replica sets create pods. Now that makes sense. But there's another use case in the way that people have actually started using custom resources, and that is for state management. So they'll create a custom resource that represents like an EFS file system or something. And because of that, the sensitivity to what a custom resource can do is essential, because when you delete a custom resource definition in Kubernetes, it automatically causes a cascading delete of every single resource out there that uses that custom resource definition. So the problem is that chart maintainers come in all shapes and sizes, so to say, different levels of experience. And a chart maintainer could really radically jeopardize what you're running on the cluster if they're not writing, if they're not correctly deploying and administrating the custom resource definitions. So that's why for the longest time, it's just been left up to you to figure out how you deploy it so they don't take responsibility for it. So this goes into a whole lot more detail, more than I have currently absorbed. A couple of the other interesting things were just like, a lot of these problems would be solved if you could just have concurrent versions of a custom resource deploy at different versions, but that's not how it works. And magically behind the scenes, if you upgrade a custom resource and other things are expecting a newer version of it, it's not going to error necessarily. It's just going to keep working. But the schema of the custom resource might have changed. So there's real uncertainty if, what is the outcome or the behavior. So yeah, we'll share this link here to read up on why custom resources are such a incredible pain. Anyone have something to add to custom resources in Kubernetes? All right. So yeah, those were my announcements. Let's get to Q&A. Do we have any Q&A yet already posted to Slack? Let's see. Mohammed asks for the next office hours meeting here. Mohammed, are you on the call today? Doesn't look like it. Well, let's see if he joins a little bit later. He's usually on the call here. So let's hear on Friday, Matt Gowie. Matt, are you on the call?
Yeah, I'm here. How's it going?
Awesome. Pretty good. Pretty good. What was that? What were you just? Oh, yeah, we just see here Mohammed here too. So, well, let's get to what you were saying here, Matt, since you're above on the list here, I guess. And as that, so I believe we Matt says, I believe we talked about this before in office hours, but I'm going to bring it up again as a topic that I feel doesn't get enough attention, which is how to manage Terraform dev, stage, and production releases when you're utilizing Terraform workspaces, meaning that you're using Terraform workspaces rather than a directory structure on disk. So let's see what the current conversation is below here. So Matt writes, for my largest Terraform project, which is a couple of dozen root modules, we utilize the develop branch together with master and a release branches, and add some things and add some release process around promoting changes between these branches. This works well in some regards, but it's also difficult in that upgrading our automation to Terraform 1.0, for example, requires that we roll everything forward as fast as possible because that change isn't held in isolation on the branch. Anyways, looking to refresh on this topic and particularly about how Cloud Posse handles it. Zach adds here, my company was using branches the same way when I arrived, and I got us off of that as fast as I could for those same reasons and moved to a directory separation. And that was an exhausting process, but managing the promotion across because it was an exhausting process of managing the changes between branches. Yeah, I agree with that. Mohammed says, the most asked question, I would move away from branches and use folder separation. We also used to have QA and prod branches, and it was a nightmare to suggest to only use short life branches and pull requests for code review. Everyone's talking about monorepo and monobranch as a single source of truth with daily pull requests. Now, the magic happens when your CICD process should be smart to know which folder should apply in which order, and you can control releasing by promoting changes through the environments with simple testing at the end of every, yeah. So yeah, I think we got the gist of it here. And I will represent the camp that does it the Cloud Posse way, which is a pretty novel way of doing all of this. And then there's the most, let's start like by saying like the absolute most conventional way that companies are managing different environments is by having a directory per environment in some kind of a monorepo with the configuration in there representing that environment. So it's trunk-based development, and it is the obligation of engineers to have some process to promote a change from dev staging to prod or whatever your process is. In practice, that's also still a real pain in the butt, right? Like who's doing this accounting to make sure that these stages are the same? And you could say Git is doing that accounting, but Git isn't really accounting software. It's like the database or source control. You don't visually see how changes have moved or progressed across all these environments. So before I keep going, am I making sense so far, Matt? Am I on the right page?
Yeah, but I'd be so far, yeah.
Well, you know, but yeah, go. Feel free to go for
I mean,
the butt.
my issue is that like, hey, hold on.
So, well, while he steps away, then let's compare and contrast this to the branch-based approach. And in the branch-based approach, this is where you have a branch per environment, for example, where a developer represents like a dev environment. And in this case, you have multiple long-lived branches, and the job is for developers to converge, all these changes ultimately all the way to production. Now, the problem with both of these approaches that I've just described, there's a very big problem, in my opinion, with both these approaches, and that's that Terraform is not like your traditional web app when you're deploying it, and yet we're taking concepts of web apps and applying it to Terraform. And I agree that's how I want it to work, but in reality, that's not how it works. So this is where those of you who have heard me talk about this before, I get up on my soapbox and I say Terraform is really, like a database migration tool where you're running database migrations outside of transactions. So when stuff doesn't go well, it's up to you to figure out how to do that rollback. There's no obvious way how to do that rollback. And the naive ways could be very dangerous. Like you actually lose information if you just did an automatic like apply of the last commit or something. That might not be actually the right course of action. All right, so this is why Cloud Posse has evolved a different way of doing deployments. It comes with trade-offs. But before I get to that, now we got Matt back. So Matt, where were you going?
Yeah, so sorry about that. But yeah, my butt is that if you do everything with no branch configure, like no separate branches, so it's all trunk based, it's all just, hey, merge to main. And then you also don't have the directory structure. then you have no way of, let's say you're not ready to roll out a release to your production environment for 4 weeks. You have no way, like if you're rolling changes in and you're getting those into your develop environment, then you have no way to like easily cherry pick a small change into your production environment because it's all in the same repository, right? It's all in the same branch. It's all in the same structure. And that kind of leaves you in this, hey, if you need to do a hotfix real quick, good luck kind of a thing. Like, hey, locally, maybe you have to then, find a git commit that was closest to when you last deployed to production, hotfix that, apply it locally, and then your CI tool is out of the weeds, unless you want to completely roll back your main branch. So yeah, I'm really interested in terms of how does Cloud Posse deal with that? Like, because I'm using the sweetops system, I'm like making it work with branches, but it has its own shortcomings. So yeah.
Well, so we are doing predominantly trunk-based development for infrastructure. And this is where I really wish I had a live environment I could show on the screen to make it less abstract. Where do I start? I gotta get Andy, remind me to find a customer that will give me permission to use their live infrastructure repo for office hours. I'm sure one of our customers will go along with it. I just don't know who yet. All right, so there's a few things here. Yeah. Okay. Well. Okay. So before I get in, Imran, is there something you want to add to or tack on to Matt Gowie's question, or something you want to add?
Yeah, I just thought I do similar. I do trunk-based development, but I turn the actual thing that gets applied to my dev environment into an artifact, the whole Terraform code as an artifact, and then I can choose which artifact I want to deploy to which environment, based on something that's passed development and gone through some integration testing. So at that point there, the process is, once it passes on development, I tag that as an artifact. Whether I deploy it to UAT or prod doesn't make a difference. It's an artifact, and I can choose to whether I want to deploy that to UAT or prod, because there might be another 5 artifacts that I want to deploy. That might supersede that, but I get to choose.
Yeah, the challenge here that I've seen with that, by taking a similar approach, has been the following. So what we were doing was opening a automatic pull request for each one of those changes. And let's just say each one of those changes was an artifact. Not exactly the same, but what would happen is if the artifacts, or in this case, the pull requests, were merged in a different order, it was problematic in reality. I guess one of the problems we had in that case, because we were using pull requests, like if 2 things were modifying the same lines of code, we would have conflicts. And if you're using artifacts, you're not going to have that problem. The other thing was, though, I felt like we were encountering this thing where infrastructure, like, it was very easy to accidentally apply a later state of the infrastructure code without applying the intermediary steps. And it's become our best practice to try and apply the changes to source control 1 commit at a time, and to do that symmetrically across all the environments so they advance at the same time. And this is why I don't like that branch-based approach, because you rev dev, and then then you do 1 big rev to staging, and then another, and then maybe 2 big revs to staging, and then 1 rev to production. And it's not the same rollout process to all environments, which means that your outcome isn't guaranteed across all environments. And that's why Spacelift has this very opinionated position that it operates on push commits exclusively and is totally pull request unaware. And that is what allows you to have symmetric rollouts to all environments.
Yeah, I think on my point, we're not doing the actual, because it's actually tested against development. So we know that code works against an particular environment. Only at that point does it get turned to an artifact. So it doesn't matter because I'm going from state to state. I'm not going from individual pull requests into that state. I'm just going, here's one state, and I want to go from this state to my next state. Whatever that statement, and it's always done off the main branch.
No, that sounds pretty nice. And what are the tools you're using behind the scenes to accomplish that?
A lot of make some directories. and just basically, I just took the developer's pipeline where they do a build step, and I just basically said, well, my build step is basically I'm going to run Terraform state. I'm going to take a copy of what's in main as a zip file. I'm going to run the apply. If it succeeds, I'm going to take only if it succeeds. I'm going to take that code that I've already zipped up. I'm going to tag it as an artifact and move it into a dev repo. And if once it applies successfully and I'm happy with it, I promote that then into UAT. So UAT can only see the stuff that's in UAT and dev, and then prod can only see what's in prod.
So this is I think overall the pattern, of applying the changes to one environment, letting it burn in, pass off, whatever, then applying it to the next environment, and so forth, is pretty common in the Terraform community. One of the things that was kind of eye-opening for me was this concept of when you instead see that change in actuality, the plan across every one of your environments, so you can see what the effect of that change is before you even merge it. And that's one of the things I really like about some like Terraform Cloud or Spacelift, where if you have all of your workspaces pointing to the same code, you can see what the impact of that code is in each one of those environments. And when you merge to master, it doesn't mean auto deploy, it means auto confirm, auto plan with a confirmation step. So then you can apply those changes in each environment in the order in which you want. The one thing I don't see yet with all of these tools is a way to ensure that one happens before the other. So confirming environments in order that they should be confirmed is something we haven't solved yet. But what we do is basically, so let me just summarize what we're doing here at Cloud Posse. So one is we don't use folders to organize environments, and that was an opinionated choice because I didn't want to convey configuration information based on file names or directory structure. That's why I wanted to use what we call stack configurations. So a stack configuration is the entire configuration for some environment in a YAML configuration. Now, we keep the configuration in one place, and we keep all the code and all the modules in another. So in our case, we're trying to force convergence in every environment to one. How do I say, what we call a component, to one root module. So we have a root module, say, for a VPC, a root module for RDS, a root module for EKS, a root module for Elasticache Redis or something like that. Now, our goal, our objective is we want to have as little drift across all of our environments as possible. And we want to have the time that it takes for a change to go through all of these environments as short as possible. So in the traditional way, where we would have to open a pull request to bump it in dev, and we have to open a pull request to bump it in staging, and we have to open a pull request to bump it in prod, or et cetera, that was a very tedious and laborious process for developers to undergo. And it's conflating kind of deployment with releases. And what we did was we said, screw this, let's just have every environment point to exactly the same code, but at a commit, and let's let our continuous delivery solution, in this case Spacelift, help us control when it actually goes out to the environments. So in this case, we merge to master or main, and that queues up in our accounting system. You could say Spacelift that this change is pending in every one of these environments. So this is that thing that I really, really love, that we see that there's stuff that needs to roll out to that environment. So now let's talk about what to do in the case of a hot fix. So in a hotfix, you'd be opening up a new pull request with that change against the version that's currently been deployed that is live. Then what you would do is in Spacelift, you would have to cancel any pending changes to that environment, which is a good thing. So then you know there were pending changes. And then when your pull request is merged, you confirm and roll that out. And then you have to open up another pull request to move the tracking branch up when you want to actually deploy the rest of those changes. So is that beautiful? You know, I wish hot fixes were a more straightforward way of doing it. I think the fundamental problem is accounting and keeping track of all what is actually gone out to production. And that's why I like Spacelift as that kind of accounting software for Terraform.
I got you.
I feel like there's a lot of hand waving right there without some Terraform code. Now it's easier for you to understand because you've seen our stuff behind the scenes. It's harder for a lot of others to see it because they haven't seen our stuff behind the scenes.
Yeah, but it's useful for me to hear you like kind of explain the way you would go about a hotfix. That's the one thing that really bugs me about not really having branches. But and I also I've had two teams that I've worked with using like the sweetops approach that have been like, oh, but we could just deploy to prod by hitting this confirm button. Like, isn't that sketchy? Like, you know, and I think that maybe the answer there is more just access control or like
exactly. That's a policy. That's a policy. Yeah.
Yeah.
And what we've rolled out now with our module for Spacelift is that you can customize the OPA policy per stack. So it's very easy to come up with a policy now that restricts what you can do with prod and who can make that confirm those changes to prod. And we are working with Spacelift behind the scenes too. There was one thing we needed, then one bit of extra metadata they needed to pass to the policy engine. I forget what it was, but with that, then we could say that, well, you can't confirm prod if staging wasn't confirmed. And you can't confirm staging if dev wasn't confirmed. And this is all using just pure Rego. So it's not saying like it's what Spacelift can or cannot, it's not that. It's what you can define as a policy, which I love.
Yeah, Rego is awesome. That's a beautiful thing. Okay, I look forward to this being a recording snippet on YouTube that I can share with a team or two.
Yeah, for sure, Andy. We'll get to that. All right, let's get to the next question. Mohammed, are you standing by?
Yep, I'm here.
Cool. So Mohammed, you have a Docker Compose question here, and you're asking, you have so many Docker compositions to manage, many different solutions like GitLab and Vault and Jenkins, Nexus, etc. And you need a solid reverse proxy to replace Apache HTTPD. So your question is like, should you use Nginx, Console, Traffic, or something else? And let's see what Pepe chimed in on here. Pepe said, you forgot Varnish. Yeah, so I guess I would, how would I frame this? There are probably 24, 3 different reverse proxy solutions out there. And the one that everyone cuts their teeth on because it was one of the more popular ones originally, it was Nginx, and let's not forget HA proxy. So that didn't make the list, but that's not cool anymore. Console, yeah, I don't have firsthand experience using Console for this, but it looks very easy, and I love how service discovery works with Console and your ability to implement that. And then Traffic introducing a bunch of nice features to make rate limiting and WebSockets and all that stuff easier. Honestly, I would go with, I would consider a few things. One is like, what do you want to go to production with? Is this strictly a local development challenge? If so, I would go with the team feels most comfortable with and using. And if no one has any recent experience with all of these, I think I would probably explore. I think I would first kick the tires on Console from this list?
Yeah, I see. I was looking for anyone who experienced this, and
Specifically
one
for
that
local development, yeah.
no, not at all. Actually, the problem is that it's used for production, so they are using Docker
Oh, okay.
Compose.
But
Yeah.
so how is the reverse proxy used in this solution? What purpose is it solving?
They want to ditch the ports. Actually, they want like to use a fully qualified domain name, okay,
Yeah,
and with
And
like
access each
subdomain.
service directly.
Yeah, subdomains or subfolders on the same domain. And currently we are using Apache, but it is a nightmare actually. Apache is configuration is like rocket science. I don't understand anything, and there is not much documentation there. So
it would be. I mean, but what like, do you want to use? Are you going to use host? So do they want to point a CNAME basically to a single port? And then access each one of these services directly by a host name or via path?
yeah, exactly. The first one by like a domain. Yeah.
I mean, this is such a this is like, let's not even overthink it. Like, dude, this is so easy to do with just an Nginx configuration that would take the host name and then just use the Docker DNS behind the scenes on the host to access those services directly. And then what I would do is probably put in a whitelist, so you only, or an allow list rather, where the allow list only permits specific hosts to be dynamically proxied automatically to the Docker network.
Yeah, I think that's possible. Yes, yes.
I think that's probably like 5 lines of Nginx code.
Yeah, that's how we did it with Apache. The problem is Apache is, we need something new. Traffic has a nice feature that it integrates with the Docker socket. So you can figure out, you can read all the networking of Docker and all the containers
but you
that
even
is
need
running.
That. But you don't even need that, I think, because on Docker network, the name, if you name your containers this way, those are discoverable just using Docker DNS.
Exactly, but traffic offer you like a healthy check on these DNS, actually on the internal DNS. That's why I think.
But what are you getting with a health check? It's like on a single node, right? This is all Docker Compose. Are you using Docker Compose with Swarm or something?
No Swarm here.
Yeah, so it's just local host. What the heck is a health check getting you? Right?
Yeah. Actually, the whole solution I'm not very convinced with. Actually, why not using like Kubernetes or OpenShift, since they are all containers, right? So, but it is what it is. What can I say?
Yeah, they're deploying this kind of like dedicated single tenant in the environments for like a dev team or something, or
dev stage and prod. The same Docker Compose is replicated on 3 virtual machines, actually.
Yeah. Well, let's open it up. Anybody else have any thoughts on this one?
There's also a Docker image for like a reverse proxy for Nginx that already exists. That's already works pretty well.
Out of the box, it'll help him accomplish this exact thing.
Yeah, pretty sure.
Oh, really? Yeah, if you can quickly Google that one, maybe share that one in the chat as a thread.
Yeah, that would be helpful. Thank you.
Yeah. Cool. Well, let's see. What are the other questions here? Mohammed. Yeah, Mohammed had a good announcement. It's interesting to see another acquisition in the SecOps / shift left space. So AquaSec has acquired TFSec. TFSec being one of the original linters kind of for Terraform to identify obvious security misconfigurations. Thanks for sharing that, Mohammed. All right, let's see here. So Heath Snow has a question here. This is great. You guys asked so many good questions today. I'm curious what the test workflow looks like in the Cloud Posse Terraform repositories. Rather selfishly, I want to finish up this pull request here, and the feedback loop testing methodology is keeping me from completing it, and thus I'm using a fork in the meantime. So Heath, are you on the call today?
Yes, I am.
Awesome. Well, let's see if we can, well, we're not going to do live code review here, but let me see if I can fully understand what you mean by the workflow here. So on this module, the auto format in this case is failing. Is that what you're concerned about?
Well, it's kind of just a general test overview kind of thing. I know there's a context TF in all of your repositories, which I've sort of just ignored. And I've opened a lot of pull requests and got a lot of stuff merged, but this particular one I'm having issues with. So I just wanted to know kind of what's going on in general.
Yeah. Yeah, well, let's see where I start here. I'm not sure if I'm going to end up answering directly your question, but it's a good question overall. Like, how is Cloud Posse managing, this process of open source software with an enormous community, hundreds and hundreds of repos, and a small team, and too many customers? No, so we've had to grow up along the way here, and we are pushing the envelope of what most organizations and companies have to manage. So just the sheer number of repositories that we have. So in this case, like Terraform repos, 182 Terraform repositories, and most of them are going to look like this: updated 2 days ago, 2 days ago, 2 days ago, etc. And there's just tremendous activity. So the way we accomplish this is a couple ways. One is, you see, we have a lot of people in our organization here, and we have a troop of committed contributors that we invite into our organization and help with part of our code review process. In order to make that work, what we've done is we've set some guidelines. If you go over to docs.cloudposse.com, we have under, under community resources here. This is the best place to kind of learn a little bit more about how we think about our community and our repos. We talk about, like, when should we be, cutting a release? Well, we cut a release on every merge to master. And, what are, our code review guidelines, like what are we looking for? We want to make sure the READMEs are up to date. We want to make sure that the code has been linted and that it's formatted correctly. And, bonus points for our contributors updating the Terra tests with sufficient tests. But honestly, most people who contribute are also not Go developers or are intimidated by Terra tests. So since we prioritize overall accepting changes and advancing our module ecosystem over making sure that we have proper test coverage, because we would shun probably 98% of our community if we did that. We have so therefore our approach to testing is also laid out here, and we have a kind of philosophy that, just running Terra test and validating that the module plans, applies, and destroys catches like 80% of the issues that we're concerned about. It's so frequent that you can even break the destroy process. It's weird, but you can break the destroy process with a simple change. For example, deleting some module in there. And we therefore run Terra tests for that. And then the other challenge is against what version of Terraform. So what we do is we default to extracting. We have some bash sed grep stuff that pulls out what it thinks to be the best version of Terraform to test this module against. But if we go into one of these repos, and yeah, I was just rolling the dice here that this would have a pull request in here, and it does. So if we wanted to test this against some other version of Terraform, we can always come over here and we can say like Terraform 0.13 instead. Like this is the version we want to test it against. I would say in an ideal world, we would have tests complete for every version of Terraform, and we would be able to determine what the module's compatibility is with that. But it's also optimizing for a use case that isn't worth optimizing for that much with 1.0 being out there now. So we struggle, Cloud Posse, we are definitely, we have overwhelmed with pull requests. Like, yeah, so we, where's review request mentioned as pull signed here. This doesn't look right to me. That's it. There we go. So, org Cloud Posse. There we go. Just want to share kind of, we have 436 unreviewed open pull requests here, and it grows every day. But we've also managed to close 8,637. Pretty respectable number of pull requests to review. What we do though is honestly, people who are the most vocal get their pull requests merged the fastest. That's why we have our Slack community. That's why we have our PR reviews channel. We also have our Terraform channel. If you're not getting the attention to your pull request that it deserves, it's nothing personal. We are just overwhelmed with contributions to this ecosystem and need more, frankly, we just need more help reviewing pull requests. So if you're a regular contributor to Cloud Posse modules and we haven't for some reason reached out to you, do reach out to me. I'm Eric, or on our sweetops community, and we'll talk. I'll review what you've contributed and probably invite you to our invite-only contributors group to help review pull requests. Contributors also tend to get faster pull requests because they got direct access to other contributors.
Right. Okay. So it sounds like there's some secret sauce happening there for if there's a version of Terraform that you're actually upgrading it as part of a new minimum required version.
Yeah, though as you know, Cloud Posse, there's not too much secret sauce at all. I would say we have secret sauce that makes us awesome, but it's not secret. Everything is public on our GitHub. And if you go over here to Cloud Posse Actions, you go into our GitHub workflows, we have our test command here. It's gnarly. Dude, I thought this was going to be so easy to implement testing, and the first versions were. GitHub Actions are phenomenal when you are a closed source organization, but ironically, if you're an open source organization, the GitHub Actions are very, leave a lot to be desired. So we dispatch, every one of our repos dispatches their tests here so we could consolidate it, because there's no way to include our tests directly into each repo without just duplicating it. So we dispatch every test action run over here, but then since it's a dispatched event, we have to manually update the status on every pull request. So that's why it became so tedious here. Anyways, so this is where you can figure out, like, determine the required Terraform version. Well, here's the foo for that. All right. So hopefully that helps you navigate the Cloud Posse system if you want to expedite those pull requests. All right, let's see what other questions we got here today.
One last thing on that. If you do have a PR that's sitting around and you want it to get reviewed, there's the PR reviews channel in sweetops, which is most of the contributors are looking there and we jump on them. You just have to be loud about it, like Eric said.
Yeah. So this is what he's talking about, slack.com.
And if you're really loud, you may end up working in Cloud Posse.
Watch out. I might get Yeah, I mean, seriously though, like anybody who's interested in working for Cloud Posse, the surefire way to get hired here, make a lot of pull requests. So yeah, this is the channel here, or no, so this is office hours channel. But if anyone who wants to join the Slack, you just go to slack.cloudposse.com, and then you'll get an invitation to sweetops. And it looks like this, and we have the PR reviews channel here, which is pretty active here. So you can see everyone else posting their pull requests, and that's how they're getting them merged. Cool. Let's see here. Any more questions?
Looks like we had a question from Eric Berg on July 8th in the channel. I'm not sure we covered that.
All right, let's see here. That's probably when Eric Berg asks, I'd like to talk about approaches to distinguishing between Datadog metrics from our internal services, EKS, and the infrastructure services like the Datadog agent and the CNI, etc. Obviously, one approach is to tag each resource that identifies it as internal. I'm curious about hearing others' experiences. I wouldn't go beyond saying tagging as an answer here, I think. Any other recommendations? I think the most important thing is to treat your services in a specific way and come up with a tagging scheme there, because there will inevitably be a significant number of services that are deployed through other ways, which it'll be tedious for you to try and tag them. So maybe things that are untagged fall into a general category of system services, and then you get really good at tagging everything else that is in your control, which are your consumer applications.
Eric, I just posted something in office hours that Datadog actually has a really good article about the best practices for doing tagging. So
that's really cool. All right, well, do check that out, Eric. Let's see what else we have here. Andy, any other questions you pulled out?
Andy Roth has a question about when Kubernetes will fix the issue with jobs and init containers, and then Rizky Ramadan has a question in this Zoom chat about Terraform state backend. Okay,
yeah, let's get to Andrew's question first here. Andrew, I'm not actually fully up to speed. What is the issue with Kubernetes and Kubernetes jobs with init containers?
So a Kubernetes job will not finish until all containers in the pod have terminated. So, in a regular job, you'll have, or it's not even init containers, it's sidecars.
Okay.
Sorry, I meant sidecars there.
Okay.
And sidecars, yeah.
Very...
No, I meant sidecars there, and sidecars never terminate, so a job never finishes.
Oh yeah,
and so there's been
before.
Yeah, and it's with Istio for sure, because it's the proxy sidecar.
The proxy that gets automatically injected, possibly. Yeah.
And so there's been talk about this being fixed in Kubernetes for a long time now, but I was just wondering if anybody had heard any updates on when that might happen.
No, I don't know. Anybody solved this issue?
There's a couple of different hacky hacks, but
what do those hacks look like? High level, kind of general strategy.
It's a script that tells one container to terminate the other one.
Okay. Yeah, don't have an answer on that one.
That's the only way I've seen it done. You basically send a sig term to your sidecar containers in the main job when you're done, and then they terminate, and then the whole thing finishes.
Yeah, but it's super hacky.
All right, let's see. So, oh, and here's the link. Matt shared it for that Nginx proxy solution. Thanks, Matt. All right, let's check out this chat here. Oh yeah. We were talking.
By the
Terraform
way,
back. Yep.
Sorry, just really quick. By the way, that Nginx proxy solution got officially adopted and moved into the Nginx org now, so that's part of the core product. It was a individual contributor before, but now when you actually go to the GitHub, it's Nginx/Nginx-proxy is the actual GitHub for it. So
awesome. So it's then that's a no-brainer.
Yeah.
All right. So Andy, where was the question regarding Terraform state backend?
In the Zoom chat.
In the Zoom chat. All right. Okay, so by David Scott or Risky Ramadan. Okay, so Risky asks, I will implement Terraform for production with his team. Which place is better to manage Terraform state? Terraform Enterprise or the bucket? So so at least with Terraform Cloud, you cannot use S3 backends, is my understanding. You have to use the Terraform Cloud backend, especially if you want to leverage any of the policy controls that they have and remote runs, I believe, too. So I'm not sure if this is actually if there's a decision here. We are using S3 backends, and we're not using Terraform Cloud. We're using Spacelift predominantly with our customers, just because it's a lot more affordable and a hell of a lot more powerful, like the things you can do with it. I personally don't like the idea. So I say, in a perfect world, I guess I do like the idea that, Terraform Cloud or Terraform Enterprise manages the state. It's one less thing to have to worry about in Terraform. On the other, with it being such an exorbitantly expensive product, also then having your state for, in our case, usually, 300 environments or more, there's no break glass in that situation. If you want to get off of that, it's really going to be painful. So this is why I really love just sticking with the S3 backends for Terraform, because whether you want to use one provider or the other, you can jump, whether you want to use GitHub Actions or you want to run it locally, it all works the same. You have full control over that backend, how it works, the IAM permissions for it, the audit controls for it, the cloud trails for it, the encryption for it, everything, full control, and that's pretty cool. And shameless plug, obviously, if you're gonna do it with Terraform, you're gonna have to use the Terraform AWS TF state backend module. What is it? S3, is it? I forget exactly what we called it. Yeah, it was just AWS TF state backend. So this was the first module of its kind out there to manage the Terraform backend with Terraform. Now, there are a couple of warts with that. Terraform, there's a manual step in order to use Terraform to provision your Terraform backend. And it involves first provisioning it without a backend and then running Terraform again to import that backend back into S3. Another interesting pattern I see frequently is more frequently now is having kind of a hierarchy of S3 buckets. So you can use one S3 bucket to help you bootstrap Terraform, but then you can provision from that. You can now use that backend to provision all of your other backends, and then you don't have that cold start problem anymore. I'm curious, Matt Gowie, have you done that yet?
Done both. I used to do it where it was like, yeah, bootstrap root module that would provision the backends for all the other projects.
Yeah.
And then I recently just switched over to, hey, one Terraform state backend, and then went with the idea of just, use that one S3 bucket to store all of the
and fine-grained IAMs on it.
Yeah, and you have to get a little bit tricky with the backend configuration. If you're not using, there's workspace key prefix, which you guys folks use, and that works great with Atmos and all that stuff. But if you're not using workspaces, then you have to like actually update the key so that it'll create the folder structure
That's the biggest pain. Yeah. So that
which isn't bad. I mean, I think it's better than managing, 50 buckets for.
Yeah,
it's good. Yeah.
By the way, David Scott, thanks for finding that feature request for the EKS node group support for parallel upgrades. I was looking for it before office hours and I couldn't find it, but you beat me. So let's see, anybody opened the pull request for this yet? Yeah, nothing yet. Opened 2 days ago. We also have something, a pull request that's going to be coming out or going to get merged probably today. We're out of time for today, but just a heads up. There's been a persistent wart for all the Terraform modules out there managing EKS and doing upgrades between versions of EKS. And Jeremy on our team has, I believe, solved it now finally. So we have a pretty interesting solution here that will make in-place upgrades of Kubernetes EKS versions easier. So that's it for today, everyone. Thank you so much for attending, asking all those great questions. Want to make sure that if you haven't yet already subscribed to our YouTube channel, please do head over to youtube.com/c/cloudposse. Again, that's youtube.com/c/cloudposse for all our back episodes, as well as special outtakes from other office hours sessions. If you haven't joined our Slack yet, that's what I was showing you earlier. It's a great place to promote your pull requests if you want to get them reviewed. We have a very, very active Terraform and AWS and Kubernetes channels. So head over to slack.cloudposse.com to get access to that. If you have a phone or you like to listen to podcasts on the way to work, you can also listen to office hours that way. So head over to podcast.cloudposse.com. We're syndicated on every major podcast network out there. So very easy to listen to us. And lastly, we are hiring. So if you want to apply to Cloud Posse, head over to cloudposse.com/jobs and see what we have available there. If you are a US-based DevOps contractor, you have a lot of experience with Kubernetes, Terraform, Helm, AWS. We really want to talk with you and we'll get a call set up with you very quickly. So everyone have a great rest of your week and talk to you next week for our special edition of Office Hours, where we're going to talk about Waypoint, HashiCorp Waypoint. Talk to you then. Bye.
Thanks.